Welcome back. This is Samm. Today we are going to be solving this problem involving differential calculus, differentiation. If you have not subscribed to this channel, kindly subscribe so that you can keep getting interesting solutions to mathematical problems. If you're excited to solve with me, let's go. Okay, so we have to differentiate this with respect to x. Okay, so sine x here is the power. If it was a constant, we could bring it down here and solve on, but now it's not. So what do? We can introduce logarithm to both sides. Natural logarithm. So remember, natural logarithm is just log whose base is e. So log x base e, we call it ln x. Okay, so let's introduce that. So ln y equals to ln x squared plus 1 raised to the power sine x. Okay, now remember this law of logarithm that says log a raised to the power n. Like if you have a log whose argument has a power, that can be given as n log a. That's this n can be brought forward. So applying this law of logarithm, remember I told you that log is and ln, they are the same, just that ln has a base of e. That's natural logarithm. So we can apply that here, bringing this sine x down this way. So ln y will be equal to sine x ln x squared plus 1. Now, let's focus on this other side. Now, if you look at this very well, what you have here is a product of two functions. So one is sine x and one is ln x squared plus 1. Now, how do you differentiate when it comes to product rule? We use this formula that says u dv dx plus v du dx. That's dy dx equal to this from our elementary calculus. Okay, so if we were to apply this, what this formula is saying is that you can write down the first, differentiate the second one, that's the one, let's say this is u and this is v, so you can write down u, which is the first, differentiate the second one, which is v, plus write down the second one, which is v, and differentiate the first one, which is u, so du dx. So that's what it's saying. So if we differentiate ln y, it gives us 1 over y, right? So dy dx, because we are differentiating in y, so we add dy dx, so equal to, remember our product rule, write down the first, which is sine x, multiplied by, differentiate the second. Now if you differentiate ln x squared plus 1, remember when you differentiate ln, you have 1 over, so this will give us 1 over x squared plus 1. So that's when you differentiate ln x squared plus 1, it gives you 1 over x squared plus 1. Now remember this, what you have here is a function inside of a function. So we'll call it function of a function. That allows you to multiply by. Now when you differentiate x squared plus 1, it gives you 2x. If you differentiate x squared plus 1, that's the inner function now, and multiply it, that will give you 2x. So we have done this first part. Plus, write down the second, which is v now. The second is ln x squared plus 1, multiplied by, differentiate the first. To differentiate sine x, you have cos x. Okay, so let's put it together. So we have 1 over y dy dx equal to, if we put this together, up here, this one is like over 1 over 1. So we have 2x sine x. That's 2x sine x all over x squared plus 1. That's this part now. So we have 2x and sine x up here over what denominator is x squared plus 1. So plus this other side we have ln x squared plus 1 cos x. So from here we can multiply both sides by y. So we can multiply both sides by y. To take off this y here, we can multiply by y since we have the reciprocal of y. So let me move up there, right? So from here we'll have y multiplied by 1 over y dy dx equal to, here we'll have 2x sine x over x squared plus 1 plus, on this other side we'll have ln x squared plus 1 cos x. So this will cancel out this. Then, okay, we've not added our y, sorry. Multiplied by y. Right? So multiply both sides by y. So y multiplied by this, and then this other side multiplied by y. So our dy dx will be equal to y into 2x sine x over x squared plus 1 plus ln x squared plus 1 cos x. And now from our original question, y is what we have here, x squared plus 1 raised to the power sine x. So we can substitute that for y in our answer. So finally we'll have dy dx equal to y, which is x squared plus 1 raised to the power sine x into 2x sine x all over x squared plus 1 plus ln x squared plus 1 cos x. Okay, so that's our answer. And we can also choose to multiply, we can choose to factorize further, but this is the answer to our problem. So yeah, that's it. So if you have not subscribed to this channel, kindly subscribe so that you can keep getting interesting solutions to mathematical problems. I remain Samm.